I have used a variety of 4x4 matrix factor pairs in analyzing fermion architecture and interactions, some commutative, others not. The following is a generalization to a set of 4x4 associative-commutative matrix factor pairs of general linear or differential operators to establish as a baseline foundation to begin operating from. Because the operators are associative-commutative, the factors lend themselves to chaining, and thus, to chaining of mesons, hadrons, and to chemical compound chaining amino acid chains, proteins, nucleic acids, including RNA and DNA, and so on. MACLOF-Chaining provides a mathematical foundation describing the fields and forces linking objects, including chemical compound chaining, and possibly music and language. Note also, that since MACLOF factoring may be extended to higher dimensions, so too MACLOF-Chaining, and resulting expansion of understanding.
The scrolling background displays a summary of the theory, lemmas theorems and corollaries, and descriptions, of multidimensional associative-commutative linear operator factors, MACLOFs. Access full PDF at my links at vixera.org and academia.edu. The initial theorems and corollaries describe MACLOF factorings. The long list of lemmas detail factorings under various operator conditions. Thus, Theorem 2.1 proves that factorings under the same index for linear differential operators cap Ls and constant Ls are commutative, and so for the Helmholtzian factors and factorizations. Just as he above lemmas describe various MACLOF factorings, and Corollary 3.1 leads to factoring sums and differences for various indices.
And, as noted previously, a matrix pair may even represent mesons. Thus, the idea of chaining Helmholtzian operator factorizations arose. And so, envisioning chaining Helmholtzian operator factorizations leads to envisioning multiple associative-commutative linear operator factors, MACLOFs, using the operator commutativity where the binding force may be generalized beyond the Yukawa force, to effect chaining between objects of a general nature. Thus, just as the Yukawa force is the binder for the elementary particles using the Helmholtzian partial derivatives constants operators, the operators for other chainable objects include ionic bond Coulomb force and van der Waals forces, each of which has a second-order PDE association, just as the Yukawa force.
Using this MACLOF methodology, to chemical compound chaining amino acid chains, proteins, nucleic acids RNA and DNA and beyond chemistry as well, beyond even science, opening a grand new vista in understanding.